molecular structure. Doesn't it like have something to do with atoms or something?
Dude, come on. That's like the easiest shape ever.
Glasses?
No.
Your hat?
Yeah. Come on, dude.
What about it?
That's what it looks like.
Mickey Mouse ears?
Yes! Come on now. That's like the easiest thing to know.
Is it for like all the compounds or atoms or
No,
what?
it's just H2O.
So you got the H for your head.
Yeah.
You got the two O's.
Yeah.
That's what it is, right?
Circle. See? That looks like an O, does it not?
I think I got it. Wait.
You're wrong.
But you followed along, so you're wrong too. So, isn't it H2O? So
H.
circles will be the
2.
H. I got it. So, the Lewis dot in Vesper. Didn't we learn about Vesper? Because, I mean, I kind of blanked out every time she taught. So, what is Vesper and Lewis dot?
Vesper. It's VSEPR.
Hey Jared, how many likes do I have on my Instagram?
You have a 134.
Wait, you don't have an Instagram. So, how's that work?
I wish I had that many followers.
We don't even have that many friends total. Because obviously, look at us. I mean,
You don't need the body.
so back to work.
What
What
is Vesper?
Vesper.
It's a cool looking word. You know, all caps and all.
Yeah. I think Coach Roessler, really planned that out to emphasize it. Must be important. So, tell me about it.
I was hoping you knew.
Okay. Let's see. This thing's foggy. Well, Vesper, I believe, it's the structure of atoms and compounds and how they are connected due to 3D figures. How they look in 3D figures.
So what does Lewis dot have to do with that?
I believe Lewis dot is the atom and then the electrons that are inside of it. Like, say, you have a bean that represents the nucleus, and then that has protons, neutrons in them, and then you have, say, what's something small? The size of your brain? Okay, say that. And you surround it with the number of electrons of the certain element, and it creates a Lewis dot structure.
Oh, this dot is a dot drawn by Lewis.
We obviously don't know.
Since both my friends there are retarded idiots, I'm going to tell you what Vesper and Lewis dot really is. Vesper is the 3D model of the compound of an element or other compound. But while Lewis dot is the two-dimensional version, but each element in the compound has other dots that are around it that are smaller in size and represent the number of valence electrons for each element.
Excuse me, Professor X-ray. What exactly is the heat of fusion?
Well, Professor Jock, heat of fusion is the amount of heat necessary to convert the state of matter without changing the temperature.
So a good example would be this ice cube here. As you can zoom in, food professor. You got it? Yes, sir. Well, so technically this ice cube is the same temperature, but it is changing from a solid form, as in ice, to liquid, water, H2O. Simple enough. Over now. Ready?
Hi, my name is Professor X-ray, and today we're going to be boiling water. Right now we have a pan of water, and it has just regular water in it right now at room temperature, or we're going to heat it up to its boiling point, which is at 212 degrees Fahrenheit, 100 degrees Celsius. And the water is now boiling, and it's approximately at this temperature or higher, because it can boil at a higher temperature. Now, as you can tell, it is boiling because of the bubbles and the steam, which now you can see what boiling water looks like, and now hopefully you also know the temperature it boils at and what it looks like.
We have to study for this upcoming test.
What's next?
We have hydrogen bonds. What are hydrogen bonds?
Hydrogen bonds are a chemical bond where a hydrogen atom of one molecule is attracted to an electronegative atom. Like this.
So, I think I understand. So basically they connect.
Awesome. We got this.
So, Professor Food, do you know the specific heat of water?
Yeah, the specific heat of water is 1 calorie over gram degrees Celsius, or 4.186 joules per gram Celsius.
Ah, okay.
What is the formula for specific heat?
Well, the formula for specific heat is Q equals mc delta T. Now, the Q is the heat energy.
Yeah.
And,
Well, the M is the mass.
yeah. And then the C is the specific heat.
Yeah, and the delta T is the change in temperature.
Yeah, so I know that pretty well. So
Yeah,
you?
yeah, that was easy.
Okay, that's good.
So, what's vapor pressure?
Well, vapor pressure is the pressure of vapor in contact with this liquid or solid state.
Okay.
Do you know what the vapor pressure for water is?
Yeah, it's 0.03 atmospheric pressure.
Alright, thanks, food professor.
Well,
Polar covalent, isn't that something to do with like plants, how they get water from roots to the...
yeah, that's how water travels up from the roots, up through the plant's stems and leaves and stuff.
Okay, so like polar covalent is when the two atoms, valence electrons forming the bond, and one is slightly positive, one is slightly negative, which forms that attractive
Yeah,
thing
they
where
basically grab on and grab
they
on.
grab and they keep going.
And
Okay,
it travels
okay.
up.
I got that.
Alright, cheers.
Better hope I'm in the picture.
Is this the man?
No, that's Pimp Bane. Gosh, Ellery, thanks.
Is this the man?
Yes, that's him.
Good.
Why were you in our lab today? Oh, you're not gonna talk. Okay, I got it.
Why were you in our lab?
I was looking for the definition of a calorie. Which one? There's more than one?
Yeah, there's more than one.
Yeah, there's the one with the capital C and a lowercase c.
What do you mean?
Well, the capital C calorie is 1,000 of the lowercase c calories.
And each of those lowercase c calories weighs 4.18 joules.
Well, thanks for the information, guys. I'm out.
We didn't time out, did we?
I guess not.
Take it away.
Hello, I am Food Professor, and today I'm going to talk to you about water inside celery. Inside each cell inside celery, there is water. And whenever you put it in the freezer, the water inside each cell expands, causing the cell walls to burst. So what I have here is a thawed piece of celery. And you notice how it bends, unlike the normal celery, where it doesn't bend. Thank you.
My name's Earl Dibble Jr. and I'm a country boy. Today we're going to talk about specific heat. I have with me 2 Ziploc baggies, one with air and one with water. Now watch as I put this one with air over the... goes out. But the one with water, as you can see, does not. Closer and closer, and it still does not. That's because the specific heat of water is higher than air. So therefore, the water makes it not pop. And that's how the country boy do it.
Hi, I'm Professor, whatever my name is, and I'm here to say surface tension. Here we go. We got some ground black pepper. Need a little pinch of that. Now a little bit more, And there we go, And we need some Dawn Ultra Active Suds. Need a little bit of that on your finger? No, not that much, There we go. You need to rub that around just a little bit. Get it on your finger. Now you see, all the pepper was pushed to the sides. That's because the surface tension was broken. In other words, it was knocked out. And today's broadcast is about Amish bread. Amish bread.
Today we're going to talk about dissolving salt in water. Ma, it ain't working!
Well, you gotta stir it, honey.
Whoa, whoa, whoa. I got this. I think I got it.
Got it!
Stop.
It's Earl Doubles Jr. here again, and today we're going to talk about electrolytes and non-electrolytes. With me here I have some water and this
Gatorade.
Electrolytes react with water to form ions in solutions, and non-electrolytes have molecules. Electrolytes are ionic compounds and some covalent compounds like strong acids. Non-electrolytes do not ionize in water. Only covalent compounds like CH4 and C6H6 can be non-electrolytes. The Tyndall effect is the scattering of light on a colloid-sized particle. Water is vital to life because it has the appropriate nutrients, and we are made up of 70% of water.
Brownian motion is moving particles suspended in fluid or water. Colloid is microscopically dispersed throughout a substance. Thank you.
Water is very unique. Everything needs water to survive. Also, the Earth is about 70% water. Water is also the universal solvent.
Alright, you got viscosity of water. It is a measure of a fluid's resistance to flow. Simple as that. Got the density of water is 1. Suspension is two substances where one is thinly divided and disperses in the other. An example of this is sand and water. Desiccant. It is a hydroscopic substance used as a drying agent. Effluent, however you say that, it is a loss of moisture.
Hello, this is your captain speaking. Today we will be learning about the solution process. Saturated solutions is when there is an equal amount of powder and liquid where both the powder dissolves. An unsaturated is when the unsaturated solution is a chemical solution in which the solute concentration is lower than its equilibrium solubility. Then there's supersaturated, when there's an excess of powder in the liquid where not everything dissolves. Today in our flight we will be experiencing turbulence.
You want to put her on my shoulder?
Cowboy's
Yes.
here. Cowboy sits on the bench all the time.
Alright.
So what?
Your hair's messed up.
Oh, darn.
Oh man, hey,
Crap.
his hair's messed up,
Hair-
guys.
We gotta stop this
Somebody call in the stylist.
Alright, delete that one. Okay, lift. 1.
Get it. That a boy.
Come on, you
Good
got
form.
this.
Let's go.
3.
You got
Come on.
this. Come on.
Finish
Four.
the set.
Let's go, let's
Finish
go.
it. Come on.
5.
Yeah,
Here we go.
yeah.
There you go. Rack, get back.
You need some water? Need some water? There we go. Stuff's good for you. Drink it up. Drink it up. There we go. There we go. Mm-hmm. Oh, yeah.
Feel better?
Good set, man. Good set.
Good set.
Why are you recording?